Our two main objectives at the start is to graph what we call the sine theta graph and the cosine theta graph. They both come from our unit circle. And I'm sure you've heard of sine waves and things like that. It comes from the unit circle. So the way we do it, on our x-axis is not x anymore. On our x-axis is going to be our theta or our radian, etc. Okay, so therefore, we will also, on our y-axis, it's going to be the y-coordinate in a way. Well, I think it is actually. You'll see what I mean. We are going to start walking around this circle, and we're going to collect data as we go, and we're going to graph it on here. So we're going to walk from 0 angle. Then we're going to finish our hike at 2 pi. Therefore, our halfway mark is pi, and our quarter mark is pi and 2, and our last stop is 3 pi and 2. We are focusing on sine theta right now. Let's go for a little walk. At 0 degrees, over here, what's the y-coordinate?
0.
It's a 0. So 0 is just 0. We start, go up, climb this hill, and at the angle of pi on 2, what are we at now for the y-coordinate? At 1. If I put a 1 there, at pi on 2, we are at 1. We keep walking around. Down here, what angle are we up to? Up to pi, but the y-coordinate is 0. Pi is 0. Therefore, 3 pi and 2 is going to go negative 1. We have a negative 1 down here. 2 pi is
0.
Back to 0. What happens? These are not straight lines. These are sine waves. And they go like so. Everyone okay with that? Let's now do the cosine. So we're doing the y-coordinates, but for the x spot. It's a bit tricky. So we can sort of know that we're going from 1 and negative 1. We do our finish line, halfway, quarter, 3 pi and 2. Let's go again for another walk. Think cosine, think which coordinate?
X.
X. So now, at 0, where do we start?
1.
At 1. At 0, we are at 1. We walk up, and we end up at
0.
0. So pi on 2 is now 0. Where does pi go to?
Negative 1.
Negative 1. Okay. Then we walk down here. 3 pi and 2 is 0. Back to 0. And 2 pi is back up to a 1. This is the cosine graph. Like so. You always refer to these basic graphs because there'll be variations of these basic graphs when we start graphing. Any questions so far? Now, one thing to note. In our sine theta, we have a number in front of 1, okay, which is what we call the basic. The number in front of a sine is stretching the graph. But this is only stretched to 1. 1 up and 1 down. So that's 1. Notice this graph is sitting on 0. From here to here, the average is 0. So sometimes, for this one in particular, there is no shift. The number at the end will move it up or move the whole thing down. Our A is what we call our amplitude, stretches. Our B, what word would you use? If one thing stretches, the other thing contracts or stretch. Okay. Oh no, this is not a contraction. It's a shift. It's a shift. Okay. So over here we have an amplitude and also a shift. But this one, what's the amplitude of cosine as it is now? 1. It's 1. Okay. Because what is it sitting on right now? What y value? 1. It's not 1 though. You're close. It's a 0. It's symmetric. There's half of it above and half of it on the bottom. So for this one, it's a 0, really. Okay. Let's start graphing. Let's do this one. Y equals half cosine to theta. We're gonna graph this right now. There's one more thing that I need to do. I'm gonna wipe this off. Okay, we started with a cosine. So I'm working with my cosine graph. Now notice, what's the amplitude of this graph here? No. It's half. Okay, so if it's half, what can I do to this graph to just fix it? Half the amplitude. I could just do a cheat. Half. I cheated. Okay, I just changed the axis. Now, what is the shifting number in here? 2. It's not 2. No, 0. It's a 0. Do I need to move this graph up or down? No. Good. But there is another number that you can see, as Manny pointed out, it's the 2. Does anyone know what that number is related to? Okay. It's related to P. Now, this here, anything in front of the angle sign is your N. Because you're going to see what happens now. P stands for, anyone know what that means? Period. What's the nut? How would you explain period? Anyone? Period.
Going one spot all the way through and then back to it.
Great. Good. So, as Emily said, from one spot and returning back. But this one here, this number, this N affects the length of our wave in a way. Well, it kind of stretches it this way. Have a look carefully. So if I put that in here, my N is a 2. Okay? Therefore, my period is what? Length. It's 1 pi. What's the period of this one? 2 pi. So what can I do to the 2 pi to just change the graph? Oh, I'm going to halve it. I'm going to cheat. Instead of 2 pi, it's now only up to pi. Okay? So therefore, what's half of pi? Pi on 2. What's half of a half? Pi on 4 and 3 pi on 4. What's happening here? So remember, with the cosine, we did that. But what we have now, originally that was that. It's sort of. It's shorter, but if we wanted to go to 2 pi, what do we do again? You'd have the second period. This here, 2, tells you, I guess, how many cycles are happening within that length of time. Okay? Are we good with that? Let's try some sine graphs. Let's do a sine graph. While I write the scale up, can we now have a go at this one? I'm going to do this one here. Have a think about it. I'm throwing you off intentionally with the T, because a lot of the trigonometry questions that you do are related to time. So, let's look carefully. Sine graph. We know we're doing a sine graph. Therefore, what you can do, remember these are just sketches. If you want, just do that. Okay. Sine graph. What can I punch up here and what can I punch down there according to the equation line? It's a 5. 5 and a -5. The amplitude has stretched it up. But look carefully. What if we are looking for a period, and that's always going to be the equation for any sine or cosine, Gabe?
2 pi on t.
A 2 pi, not quite. Okay, that's t. That's sort of our angle. What goes underneath? Not the t, but the pi. Okay, because that's our variable, but then the pi in front of the variable is our n. Okay. 2 pi on pi. What happens to the pi's? 2. So we have the length of 2 for one wave. Where do I put my 2?
At the end.
At the end. What's this in here? 1. What's this? 0. Okay. Any questions with that one? Okay. One more to go. Let's go back to x now. F of x. Slightly a bit more information here. So, let's get rid of this. We have our equation here. Does anyone know what this is referring to? X is an element from 0 to 4 pi. It's domain. Good, Tim. This is the domain. Now, let's go ahead. What's my amplitude here?
-2.
It's a 2. Does anyone know what this negative thing does in any sort of graph? Okay, yep, it's a flip. Flip or an invert. inversion. So if I have this, I'm going to flip it like that. Okay? Period. What's the period? What number do I put in there?
2.
2. A period of pi. So let's slow it down a bit. Let's start off with one sine graph. Now I'm going to just make these a little bit closer, just to suit our needs a bit more. Sine graph. Yeah, we'll get there. I'm going to do it step by step. That's okay. I have this endpoint here. What should I be writing here according to my information? Excellent. What's here? Pi on 2. Okay. Good. Oops. It's going to be really rough. You don't have, it's a sketch, remember? But when I mean rough, don't be so messy that I can't mark your way. But what I'm going to do now, I have a flip. So therefore, I'm going to do what I did here. Our hill, every hill is now a valley. Every valley is now a hill. So I have this inverted. That didn't come out great. An inverted sine graph, period of pi. Have I completed the graph?
No.
Good. What do I need to do? Perry, what do I need to do? This. Yes, Perry, domain, what do we need to do? I'm only up to pi. How many more times? Three more times, good. So go 1, 2, 3. What's this here?
4 pi.
Excellent. What's halfway? 2 pi. Excellent. What's this in here?
3 pi. Level 2.
Okay, you got it. You got the idea. I haven't made a mistake in there. No. Okay, let's double check my answers. Wait, I think we've. Yeah, I think we're good. I think we're good. Yes, we're good. Any questions? The best way to draw sine and cosine graphs is do the original, start playing around with it with pencil until you get the final product. Any questions? Good. Excellent. Thank you for that. 2. Thanks for that. Pick up 10 and negative 2. This here is our x and function of x. There will be a question on graphing in your test next week.